So this video is on trigonometry and area. So we can find the area of triangles when we're given everything that we need, or if we have a special right triangle. But let's say we wanted to find the area of this triangle given here. We don't know the height of the triangle. We don't have really a whole lot. We have just two sides. So we have to ask ourselves, what could we do to get the height of the triangle? And how do we want to look at this triangle? Do we like it from this way, or should we rotate it, or something like that? So give that a little bit of thought, and think about how you might be able to do this before I've even told you anything. We need to figure out the height. We don't know the height. Okay, you'll notice that the height of this triangle has magically appeared in front of you. It's green. That's the height of the triangle. It always forms a 90-degree angle with the quote-unquote ground. Now, we really want to know the height of this triangle, so we have to just put an X there or an H there. I guess my preference would be to put an H there because it's the height. And now I need to think to myself, if I have that angle, what two things do I have? Do I have the opposite? Do I have the hypotenuse? Do I have the adjacent? So let's think about that for a moment. And we're really focusing now on this green triangle, right? We're really focusing on this green right triangle. So what do we have in this green triangle? We'll pull our live studio audience here. We have the adjacent and the hypotenuse. That's what I heard here. I disagree. I don't think we have the adjacent this time around, or the, let's see what we have here. Josh. We have the opposite in the hypotenuse. We have to go all the way across the lake to get over here. That's the opposite. And this is confusing that this is H, but this is the hypotenuse, so I'll put HYP. So that means that we have to use either sine, cosine, or tangent, which is a memory mechanism is so, ca, C-A-H, TOA. So it looks like we have the opposite and the hypotenuse, so I'm thinking we're going to use the sine function. So it's sine of whatever equals whatever over whatever. So think about your knowledge of trig, what you would put into that equation. So take a moment, think about what you would do. Okay, so word on the street is that the sine of 42 is going to equal h over 18. That's opposite over hypotenuse. Again, h was probably a stupid choice for the height of the triangle because the hypotenuse. It's a little confusing, my bad. So we have this. We can now figure this out by multiplying 18 over. So I have 18 sine of 42 is equal to the height of that triangle. So 18 sine of 42 is equal to the height of that triangle. If you could crunch those numbers for me, that would be great. I'll tell you what I came up with here. So we have for this 12.0443 is equal to our height. Okay, excuse me for that. I misspoke there apparently. All right, so now we have the height of the triangle. So if we feel like it, we could redraw the triangle if you want. I sometimes like to just so I can see it like in a less cluttered way. And I say, okay, well I know that this is the height. It's 12 point whatever, 04, I guess. And we know that this is the base, and the base is 30. So at this point, I'm just going to focus on that purple triangle there. As horribly drawn as it is, that's all right. We're going to figure out the area of that purple triangle. So what do we know to be the area of a triangle? What is the formula for the area of a triangle? The area is equal to 1/2 base, which is 30 in this case, times height, which is 12.04. Okay, and when we multiply that through, we get 15 times 12.04. So the area of our triangle, I like to do this, is equal to 180.6 units squared, 0.66 or whatever. Okay, units squared. So we should have units squared. All right. So that should be the area of our triangle. Let's just see if that roughly makes any sense. It's 180. It's 30. It's that tall. It's 12 tall. So I guess it makes sense that it would be around that much. Actually, I like that. So 180.66. Do we have an agreement on that? Okay, good. So that's really how you're going to find the area of the triangle using trigonometry, so hopefully that helps. Why don't you go on and try this problem, find the area of this triangle using trig. So take your time, think about how you're going to figure out the height of the triangle. That's probably where the trig is going to come in, and do the best you can do. All right, pause the video and go for it. Okay, sorry to our friends at home. I apparently didn't put the 64 degrees on my diagram, so just be in mind, be aware, not be in mind, be aware that that angle down there, bottom left, is 64 degrees, so write it into your note handout in case I never fixed it. All right, so continuing on, I hope you were able to find the area of that triangle. Now we want to find the area of this pentagon, and it's a regular pentagon, and it has 8 centimeter sides, so all of these sides are 8 in that case. And the first thing you're going to want to do when you have any of these figures really is you're going to want to figure out what the angle measure is. So if this is a 5-sided figure, hopefully you can remember how to deal with that. A 5-sided figure is going to be, let's see, the number of sides minus 2. So 5 minus 2 is 3. 3 times 180. There are 540 degrees in that figure, and that means that each angle is divided by 5 because there's 5 angles. So if we divide by 5, we'll have that each angle, and that is 108. So it's a total of 540, and so it's 540 total degrees, and then each angle equals 108 degrees. Okay, so hopefully we're good with that. That's probably a little bit big. So each angle is 108 degrees. We're in pretty good shape. We understand what's going on here. These are all congruent. They're all 108, so every one of those is 108. So the next thing I want to do, and I really want to stress it, is that I want to take this triangle and focus on this triangle. Okay, so I'm going to trace it a couple times, and just to prove to you how important it is and that it is the same triangle, I'm going to take it and copy paste it and move it over here. I'm having some trouble with my touch screen, but there we go. Okay, so we've got this triangle here, and the next question becomes, what is the measure of this angle here? I'll put 2 arcs through it. What is the measure of that angle? So if we think about it for a second, if this whole angle here, the blue one, is 108, then this must be half of that. So half of 108 is 54 degrees. So it's the 54 degree angle. We know that this bottom piece all together is 8, and we're in pretty good shape. If we could just figure out the area of the red triangle, then we could figure out the area of the whole thing. So basically what I'm saying is if we can figure out this area, which I'm trying to highlight right here, if we can figure out this area, then we can just multiply by 5, because there's 5 of those triangles in this pentagon, and we'll be good to go. So I'm going to draw in our height of our triangle, because obviously our height's important. So I'm going to go from here on up. There's our height. Okay, so now we have a right triangle. And if you want, you can redraw a right triangle. Kind of looks like this. This is our height. We don't know it. This here is 4. And I'm going to talk to you about why that's 4. These are the same triangle. Why is that side 4? Well, if this side is 8 and this is a congruent triangle, then it's going to be cut in half. It's going to be 4 each. Thank you. It's going to be 4 each, so we know that it's going to be 4 there. We got to take the, I don't know, so, ka, or toa. Really, our goal is to find the area of this yellow here. So do we have, let's see, if we go across from the 54, that's the opposite. Okay? If we go over here, this is the hypotenuse. It's the biggest side, so that's the hypotenuse. And this is left over the adjacent. So it looks like we have the opposite and adjacent. So, ka, toa. Which one of these are we going to use? We don't have the hypotenuse, so we want to use the tangent ratio. So we're going to use tangent of 54 is equal to opposite, which is x, over adjacent, which is 4. And if we want to get x alone, we could just multiply both sides by 4. So 4 tangent of 54 is what we're looking for. So 4 tangent of 54. That's actually the x, that's the height of this triangle. So let's go and find that out. 4 tangent of 54. So I clear. I type in 4. I don't really need to type in multiplied by. It knows 4 tangent of 54 is 5.506, I guess. I guess I'll say 5.506. So if we have that, it's 5.506, so x equals 5.506, and there we are. We're getting closer to where we need to be. We now need to know the area of this triangle. I figure, just for simplicity's sake, we'll get this over here and we'll put it in a bubble, because it's a lot going on, and if we can just put it in a bubble, I think that would be helpful. So the area of this triangle is equal to 1/2 times the base times the height. So first things first, we know the base is 8 if we're looking for the area of this yellow triangle. So maybe I'll just kind of color this in yellow so you know what I'm talking about. I'm looking for this area right here, the area of the yellow. And that's going to be 1/2 times the base, which is 8, times the height, which is 5.506. 5.506. If I crunch those numbers, half of 8 is 4, or you can just multiply by 0.5. 5.506 times 4 is really what we need to do. So 5.506 times 4 is the area of that triangle, 22.024. So the area is equal to 22.024. So area is equal to 22.024. So we have a general idea of what the area of that triangle is, the yellow, and now we go back to our shape and we say how many triangles were in there, right? And if you want to, let's just take the area of the triangle and just kind of, I guess I'll do this, see if this helps you at all. Okay, I'm going to say that this area of 22.024 is this, okay? So that's what that area is. And maybe we can even, whoops, maybe we can bold it and kind of make it take up that. So that's the area 22.024. And then we got to think about how many of those triangles are there. So I'm just going to clone this thing. I'm going to try to show you visually how many of them there are. Let me do one thing before I do that. I think this is going to be helpful, so it takes a little while to do it, but I think it's going to be a helpful thing for you. So let's take everything and move it all down for you. And then we will just take this diagram that we're looking at here, and we'll just kind of look at that on maybe just a clean slate, honestly. Okay, so here's what we were looking at, right? So we know that that yellow part is 22.024. I'm going to make a bunch of these triangles. Okay. Alright, and then the question becomes, how does this fit into the whole grand scheme of things? Let's see if I can do this with my touchscreen. So I'm going to rotate this triangle like so, and I'm going to show that that's that, pretty much, right? There's that triangle. It's not perfect, but you get the general idea. So there's that. I'm going to take this triangle here, I'm going to rotate it a bit, and I'm going to try to put it right here. It's not perfect. Again, not perfect, but you can kind of see it. It's almost worse than it needs to be. The reason that this is happening is because I have a problem with my screen. If you're in my courses, you probably know that my screen doesn't really capture things properly because my computer monitor is rectangular and my smartboard is a square. So it wrecks all of my images. Not my favorite. So it's really not working. What I was trying to do was really not working. But what should happen is that you should see that there are 5 triangles in here. So I'm just going to draw them in that case. Oh gosh. Just going to draw them in that case. So we see boom, boom, boom. So we got 1, 2, 3, 4, 5 triangles of area 22.024. So I really just need to take that area and multiply it by 5. So if I just take that and multiply it by 5, because there are 5 of those triangles that are all congruent, they're all the same size, I have 110.12, and that is my answer, 110.12. So that's exciting. We have the answer. I am way over time, so you try to find the area of a regular octagon, 8 sides, perimeter of 80. If you want to break it down into each side as 10, you can do that. That's what we're trying to do. So you try that problem, and then we are done. Okay. I will see you soon. Good luck.